Okay, good morning. Welcome. Hope you enjoyed the keynote. This session, we're going to talk about a framework and some technical details in terms of improving customer experience with real-time streaming analytics. So there's a framework that we have adopted as a best practice for streaming analytics. It's called Sense, Reason, and Act. And if you think about it, what's the most interesting, complex streaming analytics real-time system on Earth? It's us. It's humans. I mean, we're constantly sensing the world around us. We're trying to make sense of it, reason. What is it we want to do next? How do we act? And so just as an example to reinforce this framework, how did you guys end up in this session in the first place? What brought you here? Well, there's some visual cues. You're walking around, you're sensing things around you, and you may have noticed during yesterday's keynote that we're a sponsor. Informatica is a sponsor here at the conference. You may have also heard that we won the Partner Impact Award from Databricks. Or in walking down the hallway yesterday, or even today, you may have noticed a banner that says Informatica Enterprise Cloud Data Management. So all these visual cues are coming in, right? And that may have enticed you to reason, hey, I'll go take a look at the Informatica booth, see what this company does, because I'm interested in data management and real-time and analytics and AI and all that good stuff. So you may have visited our booth, seen a demo, picked up one of our white papers on streaming analytics and data engineering, and that piqued your interest. And based on that, you may have done a Google search on data engineering streaming, and that would have returned some results that included Informatica and some of the information about us. And then you're sitting in today's keynote, or keynotes, and you're thinking, okay, what's the first session I want to go to? You're reasoning, right? You're trying to make sense of where I want to go next, what I want to do next. And so you look at the online scheduler, and you look through the list, and you see, okay, AI-powered streaming analytics, we all want to improve our customer experience. We want to engage with customers more. Looks interesting. Let's take a look at the abstract. And you act on that. And you act on it by seeing where it's located, and here you are. Okay, so sense, reason, and act. Now, what does this look like in the data world? In the data world, we're sensing by going out all the way to the edge and collecting data from sensors, devices, machines, mobile device, call detail records, real-time information that's coming in from all these different streams. And we're collecting it, and maybe we're depositing it on a Kafka queue or Kinesis or some messaging bus. And then the next step in terms of the reasoning is, now that I've collected and ingested all that data, how do I merge it, integrate it, combine it, cleanse it, start to enrich it, perhaps with some data that was processed in batch from a data lake or a data warehouse or some other application. And that's all being done in real time too. And then I need to act on all that information that I've combined and integrated and cleansed. And that acting is sending maybe a simple email notification to a customer, or sending a text message, or kicking off a workflow, or feeding a real-time dashboard with real-time information, okay? All right, so let's take a look at a few examples here. In the retail industry, and you'll see a demonstration of this and more of the technical nuances in terms of how we implemented this. In retail, you may want to collect real-time web searches from web logs, collect beacon data from in-store feeds, camera feeds, point of sale information, feed that into a real-time stream or a data lake, do some analytics, and then make some offers back to the customer. A very common use case. Another use case in manufacturing or oil and gas is collecting SCADA data from sensors, call detail records if you're in telco, taking all this information, doing some real-time analytics on it, and doing some detection of anomalies that might predict, when a machine or component might fail, and then schedule some preventive maintenance to make sure that the component doesn't fail before it's too late. In clinical research, in hospitals, you're collecting bedside patient data or ambulatory monitoring data. That's being fed in real time to detect disease states and provide more therapeutic outcomes for those patients. And then finally, fraud detection, of course, is another example that you hear a lot about in financial services. So let's double-click on a couple of these use cases in terms of how we're doing this for a few of our customers. I'm going to give you two examples. So the first one is a global media and entertainment company. They're collecting massive amounts of data from mobile phone and mobile application. So what's going on here is this customer provides a chatbot that's being, where responses are coming from Watson. So I want to, as a customer, I want to engage with this particular media and entertainment company, and I'm sending some messages. Watson is feeding back a response, and the ability to engage through that conversation is what they're trying to do, and trying to make that conversation more useful and guide the customer behavior. This information is being fed into Amazon Kinesis in real time. And then Informatica is picking up all those streams, aggregating it over the users and the topics of that conversation in real time, running that in Spark streaming, and then feeding that both into the data lake to do some batch processing. And that batch processing is integrating the data with some offline information in the data lake, preparing the data, feeding it back into Watson to improve the machine learning and to improve the quality of the responses back through the mobile app to the customer. So a complete closed loop there. The second example is one of the largest Indonesian conglomerates. They built their own financial payment service platform, kind of like PayPal or PayMe. PayMe was mentioned in the keynote this morning too, but it goes a bit beyond that. So they, in Indonesia, this conglomerate has literally over 100 million customers. They're processing hundreds of millions of transactions. They service 100,000 merchants. All this stuff is processing data through payments, purchasing transactions that take place in some of their malls where their merchants reside. And what they're doing is the consumer off to the left has their mobile phone. Maybe they're topping up their cash cards on their mobile phone, making purchases in store or payments. All these transactions are being fed into Kafka, and then Informatica is picking it up once again, like in the previous example, integrating these streams and feeding it into both a data lake, okay, for offline batch processing, and also into Kinetica, which is their real-time event processing engine. And so what's happening is they're matching the data against rules in the engine, rules that have been defined to define the next best action for a customer, and then sending an offer, like a promo code or a next best action offer to the mobile app so that the consumer can respond to that while they're shopping in the mall. It's also detecting fraudulent activity in real time. With that, I'm going to turn it over to my friend and colleague here, Vishwa, who's going to describe how we did it and then show you a demo. Vishwa?
Okay. Thanks, John. Hopefully you can hear me at the back. Yeah, so as John said, we have sense, reason, act framework, right, for handling eventing data that's coming through your system, right? So what is the reasoning process? So since he described, you have data coming from IoT and various streaming sources, how do you reason the data that's coming in? So you apply reasoning techniques on the data. So how do you get those reasoning techniques? So it could be as good as I want to persist this onto a lake, or it could be I want to act on this data in real time, right? So that whole reasoning is coming from the dynamic context that you have built within your organization, right? So it could be the models that you have built or the rules, like John explained in the context of OO, right? Or it could be predictive modeling that you have actually developed within your organization that you want to apply or operationalize as a part of the streaming ETL process. Or it could be patterns, the patterns that you detect within your data that you want to apply reasoning on, right? So that plays a very important role in how you act on that data, right? So that the dynamic context you have developed within the organization using the historical context that you have gotten from your enterprise data or from your external data, which is social media feeds or partner data or any of that kind, right? So, John, where is? Oh, sorry. Thanks. So when you look at customer expectation from a streaming analytics solution, right? So sorry for the very busy slide here, but from a sense, reason, act framework, you see that there is, on the sense side, you have connectivity. Connectivity, you know that streaming sources can be variety of types, right? And the volume of the data as well as the type of data that's coming in, right? So you have sources like MQTT, OTP, OPC, HTTP, etc., which is coming in, and the data is structured or unstructured and semi-structured in many scenarios. And you want to load that onto cloud data lakes like S3 or Redshift or ADLS or Kafka, right? So you want to ingest that, right? So which means that the solution that you have needs to provide a versatile connectivity to your source systems as well as the target systems, right? Edge processing. So I'm sure you would have heard about the fog computing in the current scenario, right? So many customers want to push on the compute to the edge so that they can take advantage of the massive computing power available at the edge devices. So customers want to apply simple edge processing, which could be filtering out bad records or applying or enriching the data with the metadata information so that you can make more sense out of the data when it is actually ingested, right? And if you move on to the reasoning side, schema drift. So I'm sure you would have faced these problems when you start your streaming analytics project, because the data come from the streaming sources change over time, right? So as we call it, dynamically evolving schema, right? So it is important that the solution that you have addresses that use case of automatically addressing the schema drift or the schema evolution and help you in that journey, right? And on the streaming analytics side, if you look at, you should be able to apply transformations on the streaming data, which is, it could be aggregations or expressions and data quality, data masking, and those kind of techniques in real time before you ingest that, right? And finally, on the action side, serverless and ML operationalization. So you need to be able to operationalize your machine learning models as a part of your streaming process, so that the models that you have built within your organization, you can operationalize them and use them in the streaming analytics application that you have built. So those are the expectations that we hear from customers when we speak to them in the whole streaming data management journey. So what does Informatica have to offer for the streaming data management, right? So we have, again, we follow the similar patterns, sense, reason, act, where you have data coming in from transactional systems like your databases, CDC, which you are ingesting, which we can ingest into a messaging system like Kafka, or the data coming from your IoT streaming sources, social media, web blogs, etc., that you want to ingest that into either a messaging system or onto a lake, right? So we help you ingest data, capture and ingest data, and then once the data is in a messaging system or on a lake, we can apply various transformation techniques on the data as the data is going through the pipe, right? So you can parse the data using intelligent parsing techniques that we have, or you could apply expressions, transformations in real time as the data is going through, and push it down to Spark or Spark streaming or Databricks, so that you can design the flows in our solution either in batch or in streaming mode, and then push down the compute to Spark or Spark streaming or Databricks within the single application, so that you can build batch and streaming pipeline within the single platform. Right? And then you can operationalize actions, which could be, as John said, feeding to a real-time dashboard, or it could be triggering an alert on your mobile device, or it could be triggering a business processes through application integration solutions that you have, or it could be just persisting the enriched data onto a lake. So those are some of the actions that you can take on the streaming data. So let's dive deep into some of these solutions that we have, right? So we have recently announced a cloud-native mass ingestion solution for streaming, which would help you ingest streaming data from a variety of sources, whether it's logs, IoT, Kafka, etc., into your lake or into a messaging system using this solution. As you can see, it addresses two use cases, right? So you can ingest data from your IoT streaming, etc., onto a messaging system like Kafka for real-time analytics. So you could apply real-time aggregations, real-time operationalization of actions, etc., or you could load that into a data lake for your batch and machine learning use cases, right? So the consumption actually happens from ingestion happens in real time, and the consumption happens in a batch mode here, and in the top flow here, so the ingestion and consumption happens both in real time, right? So it addresses both those two use cases that would help you either process your data, streaming data in real time, or in batch based on your use case within the single platform. So how do we parse the data, right? So as you know, the data comes from your streaming sources in variety of formats, and also schema drift is an issue, right? So what it requires is an intelligent parsing solution, which would help you ingest the data or parse the data as you ingest, right? So we have intelligent structure discovery, which would help you ingest, parse the data as the data is going through the pipe, right? So you can see that we have machine learning algorithms which will help you identify the structure of the data, and you can choose in a visual environment, these are the elements of the data that I want to use for my further analytics, and then parser automatically creates that, and you can use that in your analytics environment, right? So let's see how we actually make use of that, right? So if you see, sorry, I should have done the bottom part. But if you see the earlier original log, right? So and there's a new log which is coming in, new version of log. It has new columns that is coming in, as well as there are some blank columns, and the data format of a column has changed. So all these are automatically addressed. This is actually what we call a schema drift or data drift, right? So which is automatically addressed by our solution, which means that you don't have to stop your flows for you to make these changes and then go back and rerun them, right? So this is automatically taken care of by our machine learning algorithms that we have built into our parsers. I'm sure you're already aware of what Spark structure streaming is. For the people who are not very well versed with it, I thought I'll give you an introduction into Spark structure streaming, right? So what is structure streaming? It's a high-level API built on by Spark for handling both batch and streaming within the same similar interface, and it can handle streaming data based on event time, and instead of processing time, which was used to be the thing with Dstream earlier, and it can handle out-of-order data in a guaranteed delivery mode, right? And it can also support output modes, which is either append, complete, and update, right? So you can actually know more about the structure streaming in the link here. But what is really the motivation for structure streaming, right? So if you look at, there are two major things, right? One is with Dstream, streaming and batch needed separate implementations. So streaming was managed by streaming context, and batch was managed by SQL context, right? So Spark actually unified these APIs to make sure that you don't require a separate implementation for streaming. So one of the things that the customers were worrying about in the past was that streaming requires a separate pipeline. I don't really want to manage two different pipelines, one for batch and one for streaming. So structured streaming unifies that with the help of common implementation for batch and streaming. And it also, to top it, it also provides two key things which customers always ask for. One was event time aggregation, which was, if your data comes from your IoT or those sources which have sketchy networks, and it's important that you process the data in the same order as it was generated at the source. So that's something that it provides, and it also helps you, moving towards batch and streaming within the same platform. So that's what Informatica provides by offering batch and streaming capabilities or processing capabilities within the same application. So what are we doing, right? So from Informatica side, if you look at, we support event time-based aggregation there, right? So you can see the event timestamp, which provides the event time-based. You can aggregate based on the timestamp, or it supports watermark, which will help you to get the or process the data which are arriving later than what you originally thought, which is essentially handing out of order data from the sources. Right? So those are the two key things that we have enabled in the platform. Of course, a lot of things have changed between Dstream and structured streaming, and that's one of the other advantages of Informatica, right? So where you are changing the, in fact, Spark changed from Dstream to structured streaming, and we enabled structured streaming for customers without having to go through any code changes for your use cases, right? So let's take one simple example, right? So you have data coming from your log system, right? So you see the event time on the left, and then Spark computing time. So the one which is highlighted essentially arrived late into your system, right? So their description of the actual logs, and we have batch size of 20 seconds and window of 40 seconds, and we have given watermark interval, which will define how long will you be willing to wait for the delayed data, right? So we'll see how it is processed with Dstream, right? So you have, as in case of Dstream, it is predominantly based on Spark's time, process time, right? So you have batches which run every 20 seconds, and your window size is 40 seconds, so which means every window you would run for 2 batches and then collect those 4 records. And the second batch would have, a second window would have the record 2, which arrived late, right? So which means that you are, even though record 2 technically arised or came into the system later, but it was originated earlier, and it is captured in the second batch, second event or second window, right? So which would make sure, I mean, in this case, you would process it as a different record, right? Which actually should have belonged there in that particular window. So how does structured streaming help you do that, right? So you have, we have, as I said, we have given 5 minutes, watermark delay here. So you see that even though the batches actually start at the same time, you will wait for we will wait for 5 minutes for your your evicting of the window, which means that you will be able to take the record in the same order as it was generated at the source, right? So you can see that both record 1, 2, 3, and 4, even though this record 2 came in later, we evict the window only after you get the 5 minutes interval, watermark interval, which means that you would be able to process streaming data even though they originate at the same time, at the time, and then stored in Kafka at a much later time within the same application and the same window. So how does Informatica handle adopted structure streaming. So we provide a nice looking GUI for you to design those mappings and operationalize them. But under the covers, it's actually we generate optimized Scala code, right? So which get pushed onto the Spark structure streaming for execution. So you see that this is actually what we call as execution plan, which would help you understand how the Scala code is generated from the nice GUI drag and drop interface where you design your flows and then push it down to Spark for execution. So this is actually the code which gets pushed on or submitted into the Spark cluster for execution. So we also support Python transformation so that you can operationalize your machine learning model as a part of your streaming ETL process, right? So which would help you take your machine learning model, for example, fraud detection model that John was talking about, and then put that as a part of your streaming ETL process, so that you don't have to have a separate application for operationalizing those models in your context. So this is, really the reference architecture, right? So from a data perspective, right? Streaming data perspective, you have, if you take Kafka as an example here, as a messaging system, we can ingest data from the streaming or IoT sources into Kafka, or even CDC, chain data capture into Kafka, and then use our platform for parsing, like the way we saw, execution, which is either expression or transformation or any of the aggregations, etc., that you can do to enrich the data or cleanse the data using our data quality transformations, and mask the data, mask the sensitive records in sensitive fields in the record by using our platform, and then deliver it to your data lakes or data warehouses for the batch use cases later, or you can deliver it to Kafka and also eventing and alerting for the real-time use cases that you have. So this is really the reference architecture where we can use Informatica platform for doing both batch and streaming data flows within the single platform and the experience. So let's take a look at how we have done that for a particular use case of a customer that John was mentioning about. So this is our Informatica Intelligent Cloud Services, which is the cloud-native solution that we have for streaming ingestion, right, as a part of our overall offering. So I log into that. So you see that we have the data ingestion, which is a new offering that we have introduced within our Informatica Intelligent Cloud Services, along with all the other things that we have around data integration, application integration, API portal, and among others, right? So you can click on data ingestion here. You can see that we have various folders where we have created the streaming flows. I can click on the new application here, right? So I want to create a new flow here. I can select the streaming ingestion task, and I can define you can see that it's a very simple wizard-based approach for ingestion, right? So you don't have to go through create a lot of experience or mappings for doing the simple ingestion activity, right? So you can provide a name here, like I'm ingesting a search history here. So before I go there, I think I should provide an example of what we are trying to demo, so that I forgot to give the context on that. So here is the retail example that John spoke about, right? So we have this business challenges that are coming in from the customers, right? So you have they have loyal customers who are searching online. They have both online and offline presence. They have their customers who are searching online. They are not actually buying the things that are searching online. For example, if they've searched for laptop online, and when they visit the shop, they are not buying those products, right? How do they what do they want to do? They want to track what customers are doing online and ingest a camera feed and figure out that this is the customer who's actually entered the shop, and they have these beacons across the shop which will identify whether this customer is walking into this particular section of the shop, and only when you walk into a particular section of the shop they want to trigger alerts, right? Which would help you understand, or which would provide you the real-time offer alerts so that you can buy that laptop. For example, if you've been searching laptop online and they know that you are in the shop, and based on the beacons they know that you are in the electronics section, and when you enter the electronics section they want to give out cool 25% off on your laptop's range that you've been searching online, right? So all that happens in real time, and and this whole experience is created for real-time operationalization of actions. So this is really a scenario here, right? So we have search history, that the logs that we are ingesting into HDFS here, right? And then the camera feeds are being ingested through MQTT. Both camera feeds and beacon data is ingested into MQTT in a JSON format into Kafka, right? And then we have our data engineering solution here, where you create your mapping for enriching and processing the data and taking actions, right? So the actions are written to another Kafka topic, which is where real-time dashboard is fed from, as well as real-time alert is actually triggered, right? So now we go back to our original use case, where we are creating the flow, right? So here I'm actually ingesting the search history, that the first thing that we spoke about, right? So ingesting the search history into Kafka, into HDFS, right? So in this case, so I choose the tail file here, right? And then I load that onto S3, which we are using it for this particular demonstration, right? And then I move on to this is my source and target, and then I can apply a little bit of transformations as well as a part of my flow, right? So I can choose to filter the data or aggregate the data as well as a part of the ingestion process, right? So and then I can choose runtime options, which would help me to choose whether send notifications or send email alerts in case of there are some issues in the flow, right? And then I save it, and then I go to my Explore, which is where I created all the other flows. For example, you see that we have ingest camera feeds from Kafka and ingest beacon feeds into Kafka. So those are the two flows that we saw, the ingestion flows, right? So I go and deploy all the three. So which means that these would be running now. I successfully deployed the ingest search history into file, right? And then I go and deploy the Kafka feeds. I mean the camera feeds search into Kafka. Finally, you see that these two are running currently, and this is currently deploying, right? So now I have deployed all the three into production. So which means that they are listening to the camera feed that are coming in, the search history which is coming in, as well as your beacon data, right? So all the three are ingested now. So you can actually see how the data is being pushed into, right? So you can see that there are 53 events that are coming in currently from your search history, which is being ingested into your target, which is in this case S3. So now I flip to my data engineering solution, right? So which is where you would do the processing of the streaming data. So now I ingested into Kafka. So now let's understand how I can apply various transformation techniques on the data by using the drag and drop interface that I spoke about, right? So you can see that I have the camera feed coming in from my webcam, as well as beacon data that's coming in. I use the Python face recognition algorithm. We've used TensorFlow here for using the Python transformation that we have for identifying the images. Essentially, it's you who is coming into the shop, right? And then we aggregate the data we apply window transformation for aggregating the data, right? And use the weblog, his search history, to see what the customer is doing, right? And then there's a parallel feed from Beacon, which is coming in as well. I merge these two streams, right? And use it for my Beacon data as well as camera feed to merge them together to see whether this is really the customer who's coming in and the Beacon data is matching with his or her ID, right? So I use that, and then I check for if there are any anomalies, and finally I generate an alert on the on the mobile device of the customer, provided he's a loyal customer and provided he's in the shop, he or she is in the shop, and they have been searching something online based on the history that they have done, right? So it's essentially it's going to trigger an alert on a Kafka topic which is consumed by the SMS application, right? So now I'm going to trigger some data so that I can make sense of what is really coming in, right? So this is essentially customer action, and I'm entering the shop. So I'm simulating here, right? So customer is entering, and this is really the ID, and he's getting into that section. I'm going to send this. So now that all these things are running, so we have the ingestion process running, the streaming analytics process running. What it does is it's going to trigger the alerts provided the customers really match, right? So you can see that there is this customer who's walking in, and he has been searching for some products like in the baby and toddler section, right? So you get a great exchange offer on the product available. So this is essentially a customer has provided bad review about a product online, and you want to help them make the subsequent purchase in the product, right? So it can work in multiple ways in which we can take the data from streaming data from the variety of sources, match them up with your batch data, and take actions on that. So yeah, running out of time. So just let me summarize. So in summary, we provide a multi-latency platform for both batch and streaming analytics within the single solution, so that you can operationalize both batch and streaming within the single platform, and it offers connectivity to streaming and IoT sources, and it offers a simplified experience for streaming and batch that you can use the similar experience, right? And it offers complex data parsing and schema drift capabilities as a part of our platform. So our solution offers the complete capability for you to perform batch and streaming within the single platform, as well as addressing some of the challenges like schema drift and others.
All right, thanks, Vishwa. And I think we're out of time, but if you have any questions, we'll be outside.
You will be at the booth.
Stop by our booth in the expo hall. Happy to do a more in-depth demo or answer any questions. But thank you.
Thank you so much.